Now that we've talked about exponential functions, let's talk about what their derivatives are. So here, if we have this function b to the x, where b is greater than 0 and not equal to 1 at our usual conditions, what is the derivative of that? Well, technically with the techniques we have now, there's really only one particular one that we can get our hands on. So we're going to look at the special case for f of x equals e to the x. We're going to look at this derivative in particular. Right? And just remember here, e, this is that natural number. Right? This is your 2.71812, so on. All right? So, now this exponential function, it's not any kind of algebraic function. So all those things like power rule, sum and difference rule, constant multiple rule, all that stuff, it's not really going to help us. We need to be able to figure out this derivative. So we have to go back to the definition. F prime of x. We're going to go back to the definition here. Limit as h goes to 0 of f of x plus h minus f of x over h. Okay, so let's plug all this stuff in. As h goes to 0, this is e to the x plus h minus e to the x over h. Alright, so limit h goes to 0. We need to, start manipulating this into a form that we can use. But what we're going to do here is use a property of exponents to split that part into e to the x times e to the h minus e to the x, all this over h. All right, now that we're here, notice both of these terms have e to the x in it, right? So I can factor it out of the numerator. But even further, this limit has to do with h, nothing to do with x, so I can factor it all the way out. And so we wind up with this. The h, 1 over h. All right. So now the question is, well, what is the value of this limit? All right, what is the value of that? Well, I'll leave it up to you to check the value of it. Right? Do it numerically. Make a table of values and see what's happening here. But you'll find that this should be going to 1. Right? And so we just get e to the x. That is the derivative of e to the x, just e to the x. That's it. Right? So this then begs the question, well, what about our other exponential functions? E to the x. Things like 2 to the x or 3 to the x, 4 to the x, all those other options we have. Well, we'll talk a bit later why this works out, but it'll turn out that the derivative of this thing here, it kind of looks like our exponential function up here, except we get one extra thing, and this is why we talked about the logarithm, times ln of, right? This thing here, this is just a number. Right? So it's basically b to the x times a certain number. Right? So again, we'll talk a bit later why that's true. It involves using some of those properties we talked about for logarithms, as well as something called the chain rule. So we'll leave this here, and the next one.